Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So without any further ado, let's get started. Today we are going to look at how recommendation systems can be formulated. We will use a simple example of movie co-rating system and see how we can use graph theory and network science to perform a simple recommendation task. So let's read the question first. Jack rented movies D, R and S17. Ben rented movies A and S18. Tom rented D and A. Nick rented R and 17. So what is a good recommendation of a movie for Ben? So that was the question. So before we start on the solution, we will first have a brief introduction about recommendation systems. So in our daily lives, we have seen that in many places such as on Netflix for movie suggestions and on Amazon for product recommendations, there are recommendations that we use very frequently. So have you ever wondered how these systems are so accurate? What is the underlying structure that is providing them with such great accuracy? In this tutorial, we will understand how technologies like Netflix and Amazon, on a smaller scale of course, work with such recommendation systems, specifically focusing on bipartite graphs and network projections. We'll explore these concepts inspired by real life applications and see how is it possible to leverage these two technologies for a recommendation system. So in order to understand this, first we will discuss what is a bipartite graph. So a bipartite graph is a special kind of graph with two distinct set of nodes. Now in our case, two distinct sets like users and movies are able to generate a recommendation system. But if let's say there are more number of factors in the scenario which determine this choice of movie, let's say political choice or trend, all this is also taken into account, then it might be an n-partrite graph also, that for some political choice this particular movie is more popular, for this type of trend that movie is more popular, like this. So if we want to make a more context aware recommendation, then there can be a situation of n-partrite graph which will be handled in a similar way as we are going to see next. In the bipartite graph, the edges exist only between the nodes from different sets. So there will not be a case of an edge existing between two nodes of the same set. If we understand this in a broader way, all social networks can be understood to model the relationship between users and the content they interact with, such as posts, articles or other media, as bipartite graph. Not only that, like in e-commerce platforms, these systems often rely on bipartite graphs to model customer interactions with products they predict or future purchases. So in essence, what this means is like an edge meaning is to indicate a relation between a user renting a movie in the example stated above. So if we go below, what we can figure out is that we have this type of bipartite relation. So on the left hand side, J is for Jack, N for Nick, T for Tom and B for Ben. So all these four users or viewers have their particular relationship with the movies they have rented. So Jack has rented D, R and S17. Similarly, Nick has rented R and S17, so on and so forth. So what we can determine from this is that no two members of the same set are having a relation between them. Therefore, this suits well the definition of bipartite graph. Now, what we will look at is network projections and network folding. So first, we will understand what is user projection or user fold. So this projection shows the relationship between the users based on the movies that they have rented. Essentially, it allows to understand the similarity between two users. If two users rented many of the same movies, their projection will have a strong connection, suggesting that they might like similar future movies. So similarly, we will have a graph for this one. So you see that J, that is Jack, is connected to Nick. Jack is also connected to T, that is Tom, and then T is connected to Ben. What I have used here is that if two users have one or more movies in common, then they are connected in the graph. So if we go above, we see that Jack and Nick are connected. Tom and Jack are also connected. Ben and Tom are connected. Right? So that's why we have this particular graph for user projection. Similarly, we can get an idea that for movies, this projection connects the movies based on the users who rented them. So if two movies are rented by the same users, their projection is strengthened, indicating a potential recommendation link between those two movies. So here is the graph that we'll have for the movies projection. The only thing that we'll look into is, let's say D and A have a common viewer, then D and A are connected, right? So that's how we will make the graph here, right? Next, we move to the final question asked, which is the recommendation for Ben. So since Ben is only connected to Tom, so both of them are going to have similar interests somewhat. In the projection, Ben connects to Tom, indication of similarity in interests, right? So what we find is Tom has rented D and A in the movies, and out of which A has already been rented by Ben. So there is only one recommendation left, which is D. There could have been more scenarios where Ben was connected to Jack, and then Jack is connected to Nick and Tom. In that case, the movies that are rented by Jack but not Ben would have been the recommendations for Ben. Recommendation can be either one or more. It's not necessarily always equal to 1. So that's how bipartite graph and network projections are powerful tools in building recommendation systems. By presenting users and movies in separate graph and using projections to identify the connections, we can build systems that suggest the right content to the right users. For movie rental systems to social media platforms, the applications of graph theory are vast and are continuously growing. So I hope this is now clear to you, and that's been it. If you still have any doubts, then feel free to reach out in the comment section below. If you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving.
Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.